Hey coders, welcome to second and final part of sliding puzzle game, which we are creating with vanilla JavaScript and Canvas API, no frameworks and no libraries. As we discussed at the end of part 1, that in order to make these images move around, we need to have click event listener associated with them. But since these images, even though they look like multiple images on the canvas, to the canvas itself these are just a collection of pixels. A canvas does not distinguish between them as one or different images. Therefore, we are not able to associate any kind of click event listener with those images themselves. Therefore, we have to go with defining a click event listener with the canvas itself. From there, we will figure out in which part of the canvas and therefore on which canvas tile the mouse was clicked, and from there we have to figure out the logic whether that image could be moved in one of the adjacent tiles or not. So let's go and define an event listener with the canvas. So in the function cut image into pieces, we are assigning width and height to the canvas, and underneath those two statements we are going to define an event listener as well. The event is click, and the callback function that we want to associate with it, we are going to call it move. Now let's go and define this event listener. So let's go down. We need to pass the object that was raised as a result of that event, click event. So the first thing is that we have to prevent or disable any default behavior if associated with it, just to be on the safe side. Now, since the event which is raised is a mouse event, therefore this object E consists of many different fields, but the two fields that we are interested in are client X and client Y fields. So these two fields are going to give us the X and Y coordinates of the mouse from the top left corner of the window, the browser window, not the canvas but the browser window. So we are going to pass those values to one of the functions which we need to define yet as well, and that function will return us the row number and column number of the tile in which that click event falls, and from there we will continue the logic. So we will need to define a function called getMouseChords and pass to this function two parameters, e.clientX and e.clientY. Now this function getMouseChords will return us an object which consists of a row number and column number, so we have to store it in a local variable. Now this chords consists of an object which consists of two values or two fields, X and Y. X represents the row and Y represents the column. Since we have to use those values at multiple places in this function, so we are going to define local variables and assign those fields to them so that we don't have to write the whole object name followed by the field name everywhere where we need to use it, so that we can have a cleaner code and fewer number of keystrokes. Now, since these coordinate represents a tile where we expect an image to be present, so we are going to name it tile X and give it coords.x. Now this represents the row number, and let tile Y represent coords.y. Now since these two X and Y coordinates represents the row and column of the tile where the click event took place, next we have to get the coordinates of the tile which represents a blank tile. Then we will figure out if these two tiles are adjacent or neighbors, and if they are neighbors we can swap their places, otherwise we will not take any further action. So to get the coordinates of the blank tile, we have to first of all call a function called findBlankIndex. Again we have to define this function, but once it is defined it will give us the index number, not the row and column, but the index number in the shuffled index array where we have -1 value. So we will pass that index number to yet another function which is get row columns from index, and this will in turn give us the row number and column number for that blank tile. Now store this object in a variable, let's call it blank chords, and again this will return us X and Y coordinates which represents row and column. So let's store those rows and columns or X and Y coordinates in our local variables. So let's give them name blank X and assign it blank chords.x value, and let's define blank Y and assign it blank chords.y value. Now tile X and tile Y represents the tile on which the click event took place, and blank X and blank Y represents the row and column number for the blank tile. Now when we have got the row and column number for the tile clicked and the row and column number of the blank tile, now we have to check if they are neighbors or not. So if they are not neighbors, this move function cannot proceed further and it will terminate right there. However, if they happen to be neighbors, then we can go ahead and define the logic for swapping those two tiles. So to figure out if they are neighbors or not, we have to define yet another function. So we will then check if not has blank neighbor, and we have to pass in first of all the coordinates for the tile click and then the coordinates for the blank tile. Tile X, tile Y, blank X, blank Y. Now if these two tiles are not neighbors, in that case we will simply return. That means the move function will end right here. It will not proceed any further. However, if that is not the case, in that case this return statement will never execute and we will proceed further. And the next logic is to swap these two tiles, because we have already figured out by this point that these two tiles are neighbors and they could switch their places with each other. We have to define this has blank neighbor function as well. But first let's continue with the logic for the move function. So the first thing is, just like storing the variable in a temporary variable, we have to store the pixels which fall into the tile which consists of the image. Just like swapping the values of two variables, we have to utilize a temporary variable. Over here we have to store the pixels which represents the image tile into a temporary variable, so that we don't lose those pixels, because those pixels represents our image on that tile. So we are going to name it swap image, and we have to use context.getImageData. And to this method getImageData, we have to define 4 parameters. The first 2 parameters represent the x and y coordinate from where the image should start getting copied, and then the next 2 parameters are width and height. So we want this to start from tile x times board.tile width, then tile y times board.tile height. So this gives us the starting coordinate in terms of x and y. Remember, this tile x and tile y represent just the row number and column number. We have to multiply it with the tile width and tile height of each tile so that we can move to the exact pixel from where we want this copying to start. Now the next 2 parameters are board.tile width and board.tile height. Now if you notice, this time we are not using toDataURL method to extract the data in the form of data URL and storing it in the local variable. Rather, we are using this method getImageData. Now this getImageData returns us an object of type ImageData, this thing, which is just a collection of same pixels. So over here we are storing an image data which basically stores the pixels which are placed at this position. Now you must be wondering that first time when we cut the image into multiple pieces and stored them in the array, we used a function called toDataURL. So this time why are we not using that function? We are not using that function because with toDataURL we don't have this choice to select a portion from the canvas and store it somewhere. Remember, we used temporary canvas to first place the image into temporary canvas, and then we used toDataURL on that temporary canvas, which took everything which was present on that temporary canvas and converted it into a toDataURL. But over here, we have to just take the portion which represents the tile that was clicked, not the whole canvas. Therefore, we cannot go with toDataURL function. So I hope that's clear. Now we have the pixel safely present in this swap image. Let's make a data image so that we remember that it's a data image. So the tile which consists of the image, those pixels in that tile, they are all stored in this variable swap data image. Now we are ready to remove the data or image from that tile. And to remove the image from the tile, we simply have to repaint that portion with the gray color. So we are going to call a method called fillRect once more. And since the color is already defined with the fill style, so we don't have to redefine the color unless we want to change the color. Since we don't want to change the color, so we are only calling this fillRect function. And to this function, again, we have to pass the same parameters that we use to get the data from, so that only that portion gets repainted, not the whole canvas. Now this statement gives us the illusion of the blank image being moved from its previous position to the one where we had image. Next, we have to move the image from its previous position to the one where we had blank tile earlier. So since we already have data in the form of pixels, we are going to call putImageData method on this context. And the first parameter to this method is going to be the pixels or image data that we want to put there. So copy this and paste. Now the second 4 parameters are going to be the starting position from where these pixels start inserting and the width and height. So let me just copy these parameters, and then I'll replace this tile X with blank X and tile Y with blank Y. The rest is going to remain the same. So these 3 lines actually do swap the 2 images on the screen, but we have to update the shuffled IDs function as well. Otherwise, when we next time click on any other image, then the coordinates for the blank coordinate will still be the previous one, and we will never be able to swap the correct images ever again. Therefore, we have to update our shuffled IDs function as well, because now the blank tile has moved to some other index. Now within this function, we only have the rows and columns for both the tile with the image as well as the tile which is blank. We need to get the indexes for those rows and columns. So const image index get index from quads. We have to define this function as well. So tile X and tile Y, likewise const blank index, and to this one we have to pass blank X and blank Y. Next we have to call a function which we yet have to define, and to this pass image index and blank index. So this function will update shuffled IDs array according to these 2 parameters provided. Now so far, beside defining these helper functions, the logic for moving the 2 tiles is complete. So we will define those helper functions, and then we will check if clicking on any image on the canvas does actually moves it to the neighboring empty tile or not. But eventually we will revisit this function, this move function, and we will define the logic to check if after swapping the 2 tiles, if the image is solved or not. The puzzle is solved or not. So we have to define this logic yet. But so far, let's leave this logic here and let's define those helper functions and then see if clicking on the image does actually swaps it on the canvas or not. So let's go to the top and let's see the first helper function that we have to define, which is getMouseChords. So let's go down. And this takes 2 parameters, X and Y. So we are going to define 2 functions, row, and since this X represents the client X value, that means the X-axis or X coordinate on the screen where the mouse click event occurred. So we simply have to divide that with bow.tileWidth. So this will give us the row number. Now because this X represents a pixel, so dividing it might give us a floating value. Therefore we have to pass it to math.floor so that we get the lowest integer from this. Likewise for the column, and Y divided by bow.tileHeight, and we simply have to return this as X consisting of row and Y consisting of column. That's it. You will eventually see that we need to revisit this and make some changes over here, but we will discuss this when the need arises. Okay, so we are done with this function. Now since this get row column from index is already defined, we need to work on finding the blank index function. This is also a helper function. So So for this, we are going to iterate through the shuffled IDs array because that array contains -1 in one of its indexes. If shuffled IDs at index I contains -1 as its value, then simply return that index. That's it. Okay, so find blank index is done as well. Now we need to define hasBlankNeighbor function. Okay, this takes row and column for the image tile and row and column for the blank tile. So tile X, tile Y, blank X, blank Y. Now before we define any logic for this function, let's go to the cut image into pieces function, and where I was defining board is 2 by 2, let me change this to 3 by 3 because I need to explain the logic that I'm going to define in the hasBlankNeighbor function. Now as you can see, let me close this. The puzzle has been transformed from 2 by 2 to 3 by 3. Now in order to make sure that the tile that has been clicked, if that tile has a neighboring blank tile or not, we have to rule out the possibility where it is not at all possible for the click tile to have a neighboring blank tile. So suppose I click on this tile, the first neighbor, or this tile, or this tile. All these three tiles are the neighbors of this blank tile. So if you notice, the common pattern between them is that these two tiles, they share the same row number as the blank tile. Whereas this tile, this doesn't share the row number, however, it does share a column number with the blank tile. So if the click tile does not share either the row number or column number with the blank tile, that means it is not possible for the two tiles to be neighbors at all. So we have to rule out this possibility first. So what we are going to do is that if tile X not equal to blank X and tile Y not equal to blank Y, this means these two tiles neither share row nor column number. So in that case, it is not possible for the tiles to be neighbors. So simply return false, and this function will terminate there. However, if that is not the case, then we are sure that they do share at least the row number or the column number, so we can proceed further. Now we have to make sure, suppose one of these two images have been clicked. This image is the neighbor of the blank tile, whereas this image is not, even though they share the row number. So let's look at this tile first. Even though this tile is the neighbor of blank tile and their row number matches, but they have different column numbers. So subtracting the column numbers from each other will give us either +1 or -1, depending on which column we are subtracting from. However, if we subtract the column number of this tile from this tile, then the value is going to be greater than 1. So when the rows are same, subtracting the column numbers for the tiles, if they give us 1, that means they are neighbors. If they give us any value other than 1, that means they are not neighbors. Likewise, for these vertical tiles, even though their column numbers are same, but their row numbers are different. So when the column numbers are same, we have to subtract the row numbers. So if subtracting the row numbers return us a value 1, the absolute value 1, that means they are neighbors. However, if they give us any value other than 1, that means they are not neighbors. So we have to define this logic to figure out if the two tiles are neighbors or not. If math.absolute of tile X minus blank X equals 1, or math.absolute tile Y minus blank Y equals 1, in that case they are neighbors and we can return true. However, if that is not the case either, in that case, it is not possible at all for the two tiles to be neighbors. So return false. Okay, now this function hasBlankNeighbor is defined. Let's go and check what other functions we need to define. Okay, now we need to define this last function. No, not last function. We have to define this swap index as well. So let's work on get index from chords first. X and Y. This is a one-liner function. So we simply have to return row number plus column number times board dot row columns. Next we have to define the last function, the last helper function for the move function, which is swap index. So we have got image index and blank index. So in the shuffled array, at this index, image index, we have the index or ID of the image, and at this index, blank index, we have -1. So -1 indicates that that tile needs to remain empty. Now we simply have to move -1 at this index, and at this index we have to move the ID which is currently present at this index. So let's use shuffled IDs at index blank index. We have to assign it the contents of this index. So shuffled IDs at index image index. So whatever is present at this index in shuffled IDs, now give that ID to this index. Now we can make the contents at this index equal to -1, because now this index represents an empty tile. Okay, I think we have defined all the helper functions for the move function. Now let's go and check it out in the browser if the swapping works or not. Okay, let's click on this image. So even though this image got cleared out, but the swapping doesn't happen. Let me refresh. Okay. Failed to execute put image data on canvas, overload resolution failed. So probably the number of parameters are wrong or something. Let's go and check it out on line number 106. Okay, so this put image data actually takes just 3 parameters. The last 2 are not needed. So basically we are telling through this put image data that whatever is present in this image, that means all the pixels, you have to place them on the canvas. Just like with data URL, we didn't have a choice to pick and choose from which position and the width and height that we want to copy. With the put image data, we don't have this choice to put a portion of this image onto canvas. We have to put whatever is present in this image data on the canvas. The only thing that we can define is that at which place on the canvas do we want to drop those pixels from. So just a starting coordinate, not the total width and height. Let's go and check it out in the browser. Click. Okay, now it's working. This is working. Now let's check if we click somewhere else, what happens. So technically nothing should happen. Everything should remain the same because this image is not the neighbor of the blank tile. So nothing happens, no error either. So that means the logic is working properly. Okay. With this, we have defined the swapping logic as well. Now we have to check after each swap if the puzzle has been solved or not. So if the puzzle has been solved, draw the last image for this tile, and that's the end of the game. So first thing first, let's go and define the logic to check if after swapping the images, the puzzle has been solved or not. So where do we need to define this logic? You guessed it right, at the end of the move function. Because after moving, we have to check if the puzzle is solved or not. So let's go and do that. So this is here we had left that we will define the logic to check if the puzzle is solved or not, and this is part of this move function. So the logic is going to be something like if we are going to call a function if is solved, if that returns true, in that case we want to remove the click event listener which is associated with the canvas, so that after the image has been solved, clicking it does not tries to move the tiles anymore. So the first thing is canvas dot remove event listener, which is click, and the callback function is move. Then we want to draw last tile, and then we want to receive an alert which says something like Congratulations. So now we need to define these two functions, isSolve and draw lost tile. So how will we figure out if our puzzle has been solved? So the way to figure out if our puzzle is solved or not, remember we have two arrays, tile IDs arrays and shuffled IDs arrays. The tile IDs contains IDs or indexes in sequential form, whereas shuffled IDs contains same IDs in randomized order. So after each swap, we have to compare shuffled IDs array with tile IDs array. If the elements of the shuffled ID array matches the elements of the tile IDs array at the same index, except for that index which contains -1 in the shuffled IDs array, if rest of the elements are the same, that means our puzzle has been solved. Then we can simply draw the last tile and end the game. So we are going to iterate through shuffled IDs array. So first we have to check if the element at this particular index is -1. If it's -1, then skip this iteration of the for loop. So if shuffle IDs at index I equals -1, then continue. Otherwise, check if shuffled IDs at index I does not match tile IDs at the same index. So if that is the case, that means the shuffled IDs and tile IDs array do not have same data at same locations. So in that case, we'll return false and this terminates the isSolve function. However, if we get past this for loop, that means all the elements in both the arrays are similar. In that case, we simply have to return true. All the elements except for this index are the same in both the arrays, so our puzzle is solved. Now we have to define the last function, which is draw last tile. And over here, the first thing that we need to do is get the index of the blank tile. So let blank is equal to find blank index. Now we've got the index. Now with using this index, we can get the row and column number of that index. So let coords equal get row column from index. Now this contains an object with row and column. Row is x value and column is y value. Let's create local variables to store. Now since this index in the shuffled ID, the contents at this index are -1, but the contents at this index in the tile IDs contains the actual ID. So we are going to say, let's say, so this will return us contents of the tile IDs at this index, which is another index or ID. So we are passing that ID as an index to our tile images array. So let me define one more time. This blank returns us the index at which we have -1 in the shuffled IDs array. So we are getting that index and we are asking tile IDs array to return us the value present at the same index. So this will return us the ID. We are passing that ID as an index number to our tile images array. So this will return us the image in the form of data URL, which we are going to store as image URL variable. Now let's create an object of type image. And to the source of this image object, let's assign this image URL variable or object. Since we are assigning this image in the form of image URL to this source, so that means when this image is loaded, we want the same image to be inserted in the canvas as well. Therefore, before this statement, we have to define an event listener for this image object, which is onLoad, and we want to draw this image in the canvas. So first parameter is the image itself, so this keyword. Then the next parameters are going to be which piece of this image should be copied. So starting coordinates, since we want the whole image to be copied, so 0, 0, and this dot width, this dot height. the next 4 parameters are going to be at which position in the canvas do you want to put this image on. So we have to again tell the starting coordinates and then width and height. So the starting coordinates are going to come from these x and y values. So x times bow.tile width, y times bow.tile height, then bow.tile width, bow.tile height. That's it. Now before we test this logic out, let me go back to the board and change our puzzle from 3 by 3 to 2 by 2, because 3 by 3 that means 9 tiles, so it takes a while to solve this puzzle. With 4 puzzles it's relatively quicker to solve. Okay, it says congratulations. So this congratulations is supposed to come after the last image has been placed at its position. Okay, so there is something wrong. It says width is not defined at line 163. Okay, this is supposed to be dot over here. So now let's give it another try. Now it says congratulations, but the thing is this tile is still empty. So we are supposed to get this message after placing the last image in the tile. But this last tile is image after the alert. So if we want the last puzzle piece to be drawn and then the alert should happen, then we have to do a little bit tweaking to our code. We have to go back to our isSolved function where it's being called. Now to resolve this issue, what I'm going to do, I'm going to cut this alert and put it inside this set timeout function. So this set timeout takes 2 parameters. The first one is a callback function. I'm using arrow function, and as the body of this arrow function I want to display this alert, and the second parameter is the time in milliseconds. So after this number of times have passed, I want this alert to be displayed. So now let's give it a try. Okay, now you can see we can already see the complete image, and after that the message congratulations. So now that problem has been solved as well. Now the last thing that we need to do is we want to bring this canvas from this top left corner of the window to the center. So this looks like a pretty straightforward job, but you will see that it has its own consequences. So let's start by moving the canvas from the top left corner into the center. So again, let's go back to cut image into pieces function. And after assigning height and width to canvas, let's define its position to absolute. Now set its top and left properties. Let's say 12% down, and canvas.style.left, again 12% to the left. Let's make it 25%. Now let's try to solve this puzzle. Nothing happens. I'm clicking and nothing happens. The reason because nothing happens is that when I'm clicking on the canvas is returning us the coordinates, not with respect to its starting position, like this 0, 0 over here. Rather, it was giving us the coordinates of the viewport, the whole window. But since our canvas was starting at the same position as well, so the canvas and the window both had same x and y coordinates, and we had defined the logic to get row and column with respect to those coordinates. But now when the canvas has moved somewhere else, now x and y coordinates for the window or viewport are different than the canvas. So therefore, x and y coordinates that we are getting from there, when we are trying to get the row number and column number, that's going to give us a row number and column number which doesn't exist in this canvas. Because this is a 2 by 2 puzzle, so the row numbers are 0 to 1 and the columns are 0 to 1 as well. And most likely the rows and columns that we are now getting are 3 or 4 or maybe 2. So those rows and columns doesn't exist. That's why the images are not being moved. Now to solve this issue, we have to call a method on canvas which is called this getBoundingClientReact. Now this BoundingClientReact will return us a DOM React object with some of the properties such as top, left, right, and bottom. So this top is telling us that how further away this element is from the viewport. So viewport is 0, 0, and left is telling us, let's say that the left is 100 pixels away from the 0 position, this 0 coordinate or the leftmost coordinate. Likewise, top is telling you how further down the starting position of this canvas or element is from the viewport, and likewise right and bottom. So when we click in the canvas somewhere, let's suppose over here, so this is going to return us x-axis, let's suppose 150. So the left has 100 and the click event gives us 150. So subtracting 150 from 100 gives us 50 with respect to the canvas. So 50 is inside the canvas when the canvas was in the top left corner. So we had 50 exactly at that position. So now figuring out the row and column will gives us the correct row numbers and column numbers. I hope you got what I'm trying to explain. So now let's go back to our function called getMouseCoordinates and update that function so that it takes into account these positions. Okay, so over here we have to define a method, a variable offset, and call getBoundingClientReact method on canvas. So this returns as DOM React object which is stored in the offset. Now for these statements where we are getting the row and column number, we have to subtract from this x. In fact, let me go up and define two parameters. Let's call it left, math.floor, and pass it offset dot left, because this left returns us a floating point value, so we are going to convert this into an integer and storing it in left. Likewise, for the top, math.floor offset. Now we got left and top values, so from the x subtract left, and from the y subtract top. We have to put it in the brackets, otherwise the division will occur on left and top. So we are changing the precedence. So subtract left from the x, and the value that we get, divide that value with board.tilewidth. Likewise, subtract top from y and then divide it with board.tileheight value. Now let's go and check if that logic has worked. Okay, so it's working now. But it has resurfaced the issue of displaying the congratulation message before displaying the last tile. So let's go for the quick fix and change the value, time value from 0 to 100. This will ensure the delay. Okay, give it another try. Okay, now it's behaving properly. So with this, we have reached the end of our tutorial. If you think you learned something today, please don't forget to like, subscribe, comment, and share. Thank you so much.